Hey math students, it's Mrs. Marcellus and my really wise friend, Euclid. In today's lesson, we're going to calculate the area of composite figures. Today's learning objective is, students will find the areas of composite figures by creating models and by partitioning the figures, calculating the areas of individual polygons, and combining them. Today's vocabulary is composite figure. A composite figure is a figure made of two or more two-dimensional figures. Are you ready to give some a try, Euclid? Then let's go to our first problem. For our first problem, let's find the area of the composite figure outlined in bold. We could find the area of the whole figure simply by counting up the total number of squares. The area is 23 units squared. However, we're not always going to have our figure drawn on a grid, so I wanted to use this one to give you some strategies on ways that we could divide the figure to find the area. One way to solve is to draw a line dividing this figure into a square and a rectangle. Then you can find the area of each piece and add them together. The area of the square is 9 units squared, and the area of the rectangle is 14 units squared. 14 plus 9 gives us a total of 23 units squared. You also might divide this into two rectangles. The area of the first rectangle is 15 units squared, and the area of the second rectangle is 8 units squared. Combined, this gives us our total of 23 units squared. Another thing you could do is create one large rectangle. Then you could find the area of the entire rectangle, which is 5 times 7, or 35 units squared. From that, you would subtract that extra piece, which is 12 units squared. 35 minus 12 will give you the area of 23 units squared. There are many ways to find the area of composite figures. As we proceed through the lesson, I will show you some different ways to solve. However, that doesn't mean those are the only ways. What is important is that you solve the problems applying strategies that make sense to you. Let's find the area of this composite figure. One thing I could do is draw a line here to divide this into two rectangles. Then we can find the area of each rectangle and add the two areas together. For the first rectangle, we can see that it has side lengths of 5 centimeters and 1 centimeter. Therefore, the area of this rectangle is 5 times 1, or 5 centimeters squared. To find the area of the other rectangle, we know that one side length is 2 centimeters, but we will need the length of the other side. We can use the fact that opposite sides of a rectangle are equal to help us. We know that from here to here will be 4 centimeters. Then, from that point to the top will be 1 centimeter, because it is opposite the other end, which is also 1 centimeter. The total length of this side will be 5 centimeters. To find the area, we will multiply 5 times 2 to get 10. The total area of the figure will be 5 centimeters squared from the first rectangle plus 10 centimeters squared from the second rectangle, which equals 15 centimeters squared. Of course, that's not the only way to solve the problem, so let's look at a couple more. We could divide the figure into two rectangles a second way by drawing a line here. Then we can calculate the area of the two rectangles and add them together. The area of this bottom rectangle has side lengths of 2 centimeters and 4 centimeters. To calculate its area, we'll multiply 2 times 4 to find that it equals 8 centimeters squared. The top rectangle has a side length of 1 centimeter, but we need to figure out what the other length is. Since opposite sides are equal, we know that from here to here is 5 centimeters. We also know that from here to here will be 2 centimeters, because it's opposite that other end. This means the total length of this side is 7 centimeters. To find the area of this top rectangle, we'll multiply 7 times 1 to get 7 centimeters squared. Then to find the total area of the figure, we will add 7 plus 8 and find that it is 15 centimeters squared. Another thing you could do is create a complete rectangle, then subtract the part that's not included. In the previous examples, we determined that the complete lengths are 5 and 7. To find the area of the complete rectangle, we'd multiply 5 times 7 for an area of 35 centimeters squared. Then you'd need to subtract this part that's not included. That is 4 times 5, or 20 centimeters squared. And once again, we end up with a result of 15 centimeters squared. In this problem, we're asked to find the area of the gray part of the figure. We can see that it is a rectangle with side lengths of 8 centimeters and 9 centimeters, so we know that the entire area is 72 centimeters squared. However, we have to subtract the area of the blue part in the middle. One thing we could do is divide this into two rectangles by drawing a line here. The rectangle on the bottom has dimensions of 4 centimeters and 2 centimeters. Its area is 8 centimeters squared. For the second rectangle, we know that its top length is 2 centimeters, but we need to figure out the side length before we can calculate its area. We know that the full length of the figure is 4 centimeters, and from here to here is 2 centimeters. By subtracting 4 minus 2, we know that the missing length is 2 centimeters. We'll multiply 2 times 2 to get an area of 4 centimeters squared for the second rectangle. The total area of the composite figure is 8 plus 4, or 12 centimeters squared. To find the area of the gray part, we'll start with the full area of 72 centimeters squared and subtract the 12 for the blue composite figure that's embedded in it, and find that the area of the gray part is actually 60 centimeters squared. A second way to calculate the area of the composite figure in the middle is to divide it into two rectangles by drawing a line here. The rectangle on the left has dimensions of 2 and 4, so its size is 8 centimeters squared. The second rectangle has an end length of 2 centimeters, but we need to determine the other side. The total bottom length of the figure is 4 centimeters. We know that from here to here is 2 centimeters using the opposite side of this rectangle, so we will take 4 minus 2 to determine the other piece is also 2 centimeters. When we multiply 2 times 2, we find that the area of this piece is 4 centimeters squared. Again, we can see that the area of the composite figure is 12 centimeters squared. To find the area of the gray part, we will again subtract 12 from 72 for an answer of 60 centimeters squared. A third way we might calculate the area of the composite figure is to turn it into a complete square. We know that each side of the square is 4 centimeters, so the area of the complete square is 16 centimeters squared. We next need to subtract the area of the part we added on to complete our square. Each side length of that part is 2 centimeters, so its area is 2 times 2, or 4 centimeters squared. We then subtract 16 minus 4 to get 12 centimeters squared for the area of the composite figure. We will once again subtract that from the total area of 72 centimeters to find that the area of the gray part is 60 centimeters squared. Phew, we made it, didn't we, Euclid? That was actually kind of challenging. There are so many different ways to come up with the same answer. Actually, though, I thought it was kind of fun, too. In fact, you might say it was really a hoot. Oh, come on, have a sense of humor. I thought that was really funny. Well, math students, this does conclude our lesson on finding the area of composite figures, so we're waving bye for now.